Welcome to our video tutorial for question 2 of our daily review. And question 2 is working with powers and roots of numbers. As always, I would encourage you to use the chapters of the YouTube video or check in the link of the description for timestamps to skip ahead and find the specific part for this problem that you may need some help with. Let's go ahead and start today by describing some vocabulary terms that will help us understand powers. Exponents are a simplified way for us to show repeated multiplication. And working with exponents is how we will understand powers. In this case, if I have a number like this, 3 and 6, and we've got our 6 up in the top right-hand corner, make sure that that does not look like 36, but our 6 should be a little bit smaller and in that top right-hand corner. In this particular case, 3 would be the base number, and that is the number that I am going to be repeatedly multiplying together. The exponent is the small number in the top right, and that tells me how many times I will repeatedly multiply the base number, or 3, by itself. When I put all of those things together, I'm going to create a power. So this is a power once I've written it all together. And there are two different ways we could express this power. We could say 3 to the 6th power, or we could also say 3 to the power of 6. Both of those descriptions are describing exactly the same thing, just in a slightly different way. Now, just like we said, exponents or powers are showing us repeated multiplication. So I'm going to go ahead and write this problem out. It would be 3 times 3 times 3 times 3 times 3. And a quick reminder not to make a common mistake. Common mistakes when students especially start working with exponents for the first time is they might write something that looks like this. But you have to be really careful, because 3 times 3 times 3 times 3 times 3 is not 18. That would be repeated addition, but this problem is asking us to do repeated multiplication. So I'm going to go ahead and do that repeated multiplication here down below, and I'm simply multiplying a group of 3 each time as I move my way down this problem until I've multiplied by 3 6 total times. In this case, I would end up with an answer of 729. Now, you are more than welcome to work any exponent problem out by hand like I just did here, and that's obviously great practice for multiplication. But I also want you to know I would never expect you to have any of these things memorized. So I would never think anyone should memorize what is 3 to the 6th power or what is 5 to the 9th power. So you are also welcome to use a calculator, and here's our calculator that we have in our classroom. The exponent button I've circled there. I know it's a little bit small, but it looks like an upward pointing arrow, and it's actually called a caret. If you're not using the same calculator that we have in our classroom, you can look for that same button, and it might just be located in a different spot. If you're using your keyboard on your Chromebook or another computer, you're going to find that button by pushing Shift plus the 6 button. So in order to do this particular problem, we would type in 3 and then that caret button and then 6, and we could get our answer of 729. Now let's go ahead and talk about a couple of unique powers that we might encounter. We've just said that 3 to the 6th power is 729. But sometimes we might experience some negatives with our exponents. In this case, we have negative 3 to the 6th power and negative 3 to the 6th power. And both of those things look really similar, but we're actually going to see how they might be a little bit different. And multiplying our negative exponents can sometimes be a little bit tricky here. Now we know that 3 to the 6th power is 729, and I'm going to use that information to help me to figure out the two problems that I have down below. So my first problem, according to order of operations, tells me that I must do my exponents first. That means that I am going to do 3 to the 6th power first. So I'm going to do all of that. We know the answer to that already is 729. Then I am going to make that a negative number based on my order of operations. Let's look at how this is slightly different for the problem on the right-hand side when the parentheses are around that entire quantity. In this case, we are raising the negative 3 to the 6th power. That whole quantity is being raised to the 6th power. So this problem actually looks a little bit different. And in this case, we would be multiplying negative 3 by negative 3 by negative 3 by negative 3 by negative 3. And in this case, we are going to end up with a positive 729, and that is because of our rules of multiplying negative numbers. So make sure that you're paying really close attention if you ever see an exponent that also includes a negative number with it. Let's go ahead and talk about a couple other quick examples. Things like 1/2 squared. Well, 1/2 squared would simply be 1/2 times 1/2, and that would equal 1/4. Or maybe something like 0.4 to the 3rd power. Well, that would be 0.4 times 0.4, which would give me 0.16, and then I would multiply that by 0.4 one more time, which would give me 0.064. So we're going to treat all of those things exactly the same, and you are, again, more than welcome to use your calculators, even on problems like that. One final note, if you are working with any fractions or any decimals, the exact same rules with our negative numbers would apply that we just described up above. Next, let's go ahead and talk about roots, and we're going to start by talking about square roots. We've already talked a little bit about square roots for question number 1, and square roots are simply a number that, when multiplied by itself, produces the given quantity. When we described this before, we talked about the square root of 25, and we described that we know that the square root of 25 must be 5 because 5 times 5 is equal to 25. We're looking for the number that, when multiplied by itself, will equal 25. And I've encouraged you to memorize the first 20 perfect squares, and that will help you when we're working with our square roots. However, we also have things that are not just square roots, but we have just roots in general that exist. So roots are a number that, when multiplied by itself x times, produces that given quantity. And these roots that are not just square roots become important because we might have some other things like this. We might have the cube root, or we could also say the 3rd root of 125. In this case, we're looking for a number that we would multiply by itself 3 times to give us the quantity of 125. Well, in this case, I would know that my answer would be 5 again, because 5 times 5 times 5 is equal to 125. And we could do this with like the 5th root of 32, and we're going through that same process. What would you be looking at that I could multiply by itself 5 times to get me the value of 32? Well, in this case, I would know that my answer is 2, because 2 times 2 times 2 times 2 times 2 is equal to 32. The important thing to remember about our roots is that roots are the inverse operation of exponents. In other words, this is the way that you would undo an exponent. So if I had 3 to the 6th power, the way I would undo that is I would do the 6th root of 729. Now, just like with our exponents, I don't expect you to do all of these things by paper or in your head. So let me give you a quick tutorial about how you could use your calculator to do these more complicated roots. We've already described square roots and where our square root button is in this particular case. In this case, our square root button is kind of halfway down that mark, and you're going to see that it's written in blue there. So that means that we actually have to push that second button that's on the top. So in order to type this into my calculator, I would simply type second, and then I'd hit that square root button, and then I would put 25. Now that is telling your calculator that we are looking specifically for the square root of 25. Hopefully we can memorize the first 20 or so perfect squares, and we don't need to use that square root button too often. But we also might have things like the cube root, and you're going to notice that that button is actually in a different place. So this particular place is one button above. I still need to push that second button, and then I can tell my calculator what root I am wanting. In this case, I want the fifth root of 32, and that would equal 2. So I can push 5, and then second, that fifth root of 32, and that would tell me that the fifth root of 32 is the number 2. Hopefully that gives you a good working knowledge of how to work with our powers, our roots, and how to do both of those things on our calculators.